Hello, my name is Tommy, and today we're talking about separation of mixtures. If a piece of paper is nonpolar and is used in chromatography with water as a mobile phase, which will travel farther, a nonpolar substance or a polar one? So we have our cup, and we have water at the bottom, and we have our piece of paper. Let's just say our mixture is right there at that dot. So, if it's part polar and part nonpolar, which will travel up the paper more, the polar substance or the nonpolar substance? So the way I like to think about this is that like travels with like. So a nonpolar substance is going to stick with the nonpolar stuff, and a polar substance is going to stick with the polar stuff. So the polar stuff is going to go up with that polar water and go up higher, because that water is going to climb and travel along with the polar stuff more, because it's going to stick to that polar water more. While that nonpolar stuff is not going to stick to that water as much and stay along with the nonpolar paper. So in this problem, if C4H9OH and C5H11OH were distilled, which would have a higher initial concentration? So distillation looks a lot like this. Where this is where your initial stuff is, and when it boils, we have our flame here, it'll travel up and go over here. So the way that you determine which one has a higher concentration here is which one is going to boil first. And what determines boiling point mostly? Well, our IMFs. So whichever has higher IMFs will have a higher initial concentration. So of these, they're going to have about the same intermolecular forces, but LDFs for C5H11OH are going to be higher because it has a larger electron cloud because of the extra carbon and the two extra hydrogens, and thus making it more polarizable. So C5H11OH has stronger LDFs than C4H9OH. So we know that C4H9OH is going to boil first because it has weaker IMFs and it takes less energy for them to get pulled apart and boiled, or not pulled, pulled apart from each other. So our initial higher concentration is going to be C4H9OH due to its lower boiling point, due to its lower IMFs, because C5H11OH has stronger LDFs than C4H9OH.